Hi, everybody. In Chapter 4, we're going to continue on with inferential statistics, but this time for two or more populations. In this chapter, we will compare the means of two or more populations. In 4.1 and 4.2, we're going to compare the means of two populations, and then in 4.3, we'll go on to comparing the means of three or more populations. Now, the reason we're taking two sections to compare the means of two populations is there are two types of samples that we can use. They're called independent and dependent, and the dependent ones are also called matched pair. So before we jump into this, let's talk about these two kinds of samples. For a scenario, let's consider comparing marital satisfaction among women versus among men. And specifically, let's pretend we've got the organizer of a couple's marriage workshop, and the organizer wants to compare the marital satisfaction of the women and the men attending the workshop. We're going to use really small population and sample sizes here just so that I can give you a nice little visual on the screen. So suppose there's 10 married couples attending the workshop, and the organizer, in order to compare marital satisfaction, decides to survey 3 women and 3 men regarding their satisfaction with their marriage. Now, one possible method of selection is to randomly select 3 women to be surveyed and randomly select 3 men to be surveyed. So again, we're thinking about two populations here. Population 1 is the 10 women at the workshop. Okay, so let's randomly select 3 of them. Let's say, let's say we select this one, and this one gets selected, and that one gets selected. And I think I'm going to number these so that we can talk about them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our sample from population number 1, so I'll call it sample number 1, is woman number 2, woman number 5, and woman number 10. Now we go to population number 2, which is the 10 men at the workshop. And we randomly select 3 of them. So let's say, let's say the first one gets randomly selected, and this one gets randomly selected, and that one gets randomly selected. So our sample from population number 2, that I'll call sample number 2, is man number 1, man number 5, and man number 8. These are called independent samples. The selection of women has no effect on the selection of men. We completely separately, independently selected from each population. But there's another way we could do this. So another possible method would be to randomly select 3 couples and then survey those 3 women and those 3 men. Now we're still thinking of the women as one population, and we're going to have a sample from that population that we don't have yet. And we're still thinking of population number 2 as the 10 men attending. And from that population, we're also going to pull a sample. But this time, the way we're going to get our samples is to randomly select 3 couples. So let's say this couple gets selected, and this one, and this one. Let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we randomly selected couple number 2, couple number 7, and couple number 9. That still gives us 2 different samples, a sample from each of the populations. Sample number 1 is woman number 2, woman number 7, and woman number 9. Sample number 2 is man number 2, man number 7, and man number 9. So still 2 separate populations with a sample from each population. It's just that in our sampling method this time, we basically acknowledge the fact that those 2 populations are paired up. These are called dependent or matched pair samples. The 2 samples are not independent. The choice of the men depends on the choice of the women and vice versa. At the risk of repeating this too many times, again, in both scenarios, we have 2 separate populations. We're sampling from each population. It's just that our sampling method is different.